Hello and welcome to another measurement and instrumentation class. In the previous class, we finished the bridges. We started with Whitson bridge, then Shearing bridge and Maxwell bridge, and how we can determine an unknown element's value, like a capacitor, inductor, or a resistor's value using a balanced bridge. Today, I'm going to start with a different topic. It's going to be about contactors. The reason that I've added this to this class is because some of you end up working for these companies that are in power systems, and you guys have a lot of power systems classes. And one component there are going to be switches and contactors and relays. That's the reason I've added this. And briefly after this, I'm going to take you to the lab and show the contactors and how they work. So today we're going to go through contactors, the difference between contactors and relays, the advantages and disadvantages of contactors. If you have any questions, just please stop me at any point. Now, what are contactors? So contactors are basically electromechanical switches. We have different ways that we can turn on, for example, a motor. We have just manual switches, and then we have contactors or electromechanical systems. On top, on the upper side, you can see a manual switch and the wiring and working of a knife blade regular switch. This is, can you tell me if it's a single phase or the three-phase? It's a single phase motor. Contactors can be used for single phase or three-phase, but mainly 99% of the time they are used for three-phase systems. Now, you may ask, what are the benefits of contactors? Why do we even need an electromechanical system? And I will go through that. So a contactor is an electromechanical control device, and that is used to make or break the connection between the load and power supply. It's very similar to relays, but contactors carry higher currents. They can pass higher currents. But relays have lower currents because contactors are much bigger compared to relays. And contactors for higher voltage, higher currents, but they are used for lower frequencies. Relays are usually used for higher frequencies. Contactor has, on top of the normal input-output, it also has other terminals known as normally open, normally closed, and the magnetic supply, A1, A2, that supplies the power supplies the coil, the magnetic coil. The normal open, and whenever you see a normal open terminal, means that when the system is off or de-energized, the system is open. That's the reason we call it, the contact is open. That's the reason we call it normally open. It means when it's off, just left on, a normal situation, it's open. And when the system is energized, it's going to be closed. We also have another terminal on contactors, which is called normally closed. And normally closed means when the contactor is off, it's closed. And when the contactor is on, it will be open. And I will explain where do we use these normally open and normally closed contactors. They're very important, actually, when we are using contactors. Contactors are usually used for powering three-phase devices like motors, transformers. It could be lights, for a lot of applications, but they are mainly used for three-phase connections, and usually motors are the main use of them. Contactors are electrically controlled, and contactors are often used for 15 amp and above. Relays are used for less current, like usually 10 amps is normal for a relay. This is a contactor that you're going to see in the lab. On top, you have 3 terminals, which are your inputs of your 3-phase power input, which comes from the grid, from the transformer or your input lines. Here we see A1 and A2. These two magnetize the coil. By the way that contactor works is we have a magnetic coil here, and when we power it, it's going to attract a plate, and then you have the connections. And on top of that coil, you have a spring. When you de-energize it or turn it off, the spring is going to, pull it back, and you would disconnect. So the magnetic or the coil magnetic core is energized using A1 and A2. And on top, you can see it says normal close, normal open, normal close, normal open. So 31, the one on the top is the normal close, and you have a normal close here. So this is the input of the normal close. This is the output of the normal close. And the lower one, you have normal open. So this is the input of the normal open, and this is the output normal. This is from a different angle. So the power circuit and the control system core circuit are completely separate. They are not connected in any ways. The normal close, these are the control. I'm going to just put C. And these are the power. And again, these are completely separate. And we have another control here as well, because this is the input of the normal open, and this is the output of that normal open. When we draw a circuit for a contactor, usually we draw the control circuit completely separate from the power circuit. Now, you may ask, why do we even need contactors? Why don't we just use a manual switch, by the way? Why do we go through the trouble of designing and these contactors are 10 times more expensive than a blade switch? Why do we even bother with going with the contactor? And with contactor, you need a stop-start switch. You need a different circuit, a different power source just to control the control part of it, the control diagram. Sometimes your 3-phase is very high voltage, so you can't use one of the phases for controlling. So there's a lot of complications when you want to go from a manual system to a contactor. Can you give me some reasons? Can you think of some reasons of why do we even bother using a contactor instead of a manual switch? I'm sorry? Yes, time for control limits. If you want to control something very fast, turn on and off. These are not usually actually designed to turn on and off something very fast. But if for example, you want to go from a star to delta, or you want to go from a left turn to right turn, these are much better than a blade switch, knife blade switch. Another thing is safety. If you have very high voltage 3-phase, like a transformer with 10 kilovolts, you don't want to be anywhere near that. Imagine you have a 10 kilovolt switch and you ask someone to go and turn on a blade switch. No one wants to do that. It's going to be very dangerous. So safety, number 2. Number 3, automation. You can easily automate a contactor. So for example, in a power plant or in a factory which you have hundreds of these motors, you can connect all these contactors, what we call a PLC. Have you heard of a PLC? It's program logic control systems, PLC. The Siemens is the most famous one. And it's a logic system that basically controls all your usually contactors and motors and so on. And you can use it for automation, so you can control all the motors. If you want to synchronize the motors, one very good example of that is an elevator. If you open a control box of an elevator, you can see multiple contactors, and all of that is running through a microcontroller or microprocessor, and it knows when you're pressing up or down, which floors to wait, if there is an error, if a door is not closing. All of that is going through the system, processing it, and giving the controls to the motor. Or want it to go left turn, right turn, clockwise, anti-clockwise, you want to go up, down, and so on. So another thing is automation and being able to remotely control a motor. Imagine you are in a factory and you have a motor that's on the other side of the factory. You don't want to run 1 mile to the other side of a huge factory to turn off or on. You want to be able to control it. And this, sometimes the distances are even more. So being able to remotely control that, that's another advantage as well. So these are just some of the advantages that we have for contactor. And another thing is contactors actually act like a protective system. Some of them have a heat protection system and a current protection on top of that. So that acts like an extra layer of protection. It's like a fuse that you have on the motor. So if something goes wrong, like the motor is under pressure, it heats up, or you have too much current, too much voltage coming on, the contactor would disconnect. The worst case scenario, you're gonna damage the contactor, which is $20, instead of damaging a motor there, which is maybe sometimes $5,000, $10,000. Okay, so it acts like a protective layer as well to the motor itself. Now, let's go through the principles of a contactor, how it works. We usually mainly use a magnetic contactor. It operates magnetically. It opens and closes, and it has 3 main parts. It has the coil or the electromagnetic. It has the enclosure or frame, and it has the contacts. And this picture shows the inner parts of a contactor. So as mentioned before, you have a movable contact. This movable contact, let me see if I can. This movable contact, when it goes down, it connects these two, and it connects the input of the power circuit to the output. Here you only see one phase because you're having a cut from the side, but it connects all 3 phases at the same time. So you can see the power circuit, and when this is going down, this would connect the input to the output. And on the coil, we have also the armature, and we have the coils, and we also have these springs that push it back to this normal position when it's turned off. And then finally, we have a control circuit, which is connected to our switch. Usually we have a start-stop switch, and which we push. It's called a push start and push stop system. And you can immediately see some problems with these contactors. One problem is if you have very high currents and voltages, and you close and shut them too fast, what happens is it's gonna produce some electric arcs, and it's gonna fuse them together. So one points of failures are actually these stationary and these movable contacts, which high power goes through. And we have systems to prevent them. The contactor could be used both in AC and DC. So the contactor coil may be AC or DC, or in some cases, the universal coil is used as an electromagnetic coil. The universal coils operate on AC and DC both. A small amount of power loss occurs in contacts, and an economizer circuit is used to reduce this loss. And usually because of the internal resistance that we have a small resistance in it. As mentioned, the differences between a contactor and a relay. A contactor works for high voltage, high currents, usually above 50 amps. Relays work for lower currents, below 15 amps. Contactors are slower, work on lower frequency compared to the relays. Relays are for very high frequencies. Some of these relays also have the same mechanical structure as a contactor, so they are electromechanical. Some relays are electrical pure. They use transistors as switches, like MOSFET or FET transistors or JFET transistors, something like that. For example, an inverter, a high, advanced inverter, we use electrical switch, which are transistors. But for a relay that you may use for turning on and off a light in a normal project that you do, low voltage, those relays usually have the mechanical. That's the reason when I'm walking, you actually can you hear the click? That's the relay actually. Sometimes it's a timer, but this one is the relay that you can see that can you hear the click sound? So that's actually the relay. And transistors are much faster than those electromechanical relays. And sometimes they're much more expensive. And newer ones, the newer generations, they can actually handle very high currents and powers. Actually, the advances that we had in power electronics in the past 20 years is because of these new transistors. We are able to have much higher voltage and current passing throughs and better transistor systems and fastest speeds. That's the reason we have very good inverters right now. And the rise of brushless DC motors has enabled us to make all these drones and stuff is coming from actually power electronics and these high speed switches. And you're gonna learn more about them in power electronics class. In most cases, the contactors are connected in normally open contacts and the relays are normally closed. Contactors can usually be repaired if they are broken. It's not worth it. It's like $20, $30. You just replace them. Relays are very difficult, almost impossible to maintain and repair. And as mentioned, the frequency of relays is much higher. Some applications of contactors most common application is for motor starter. It is used with overload and short circuit protection for the industrial motor. The contactors are used for automation of lights for industrial, commercial, and residential light applications. For this type of application, latch type relay is used. And this type of relay, 2 coils are used, one for open contacts and second for closed contacts. Single pole contactors are used to operate 12-volt DC load in the vehicle. Because the reason that we use contactors is because it's 12 volt, but it's very high current, sometimes 50, 60 amps. The use of contactors with the circuit breaker assures the safety of the operation of the load in industries. As mentioned, it's a protective layer. And in such an application, it is used to fast switching of the load. 2-pole or 3-wire one-phase contactors are also used to operate 240 volt AC load like air conditioners. This is for the explanation of what a contactor is. I'm going to give you an example of a contactor control diagram. So usually the contactor, we show it like this. The magnetic coil, we show it like this. And this is going to be our A1, which is the input, and this is the A2, which is the output, which is usually connected to the neutral or ground. And we usually show normal open with this sign, and we show normal close with this sign. So we can show normal close like this, and normal open with this. Sometimes in some books you see it shown like this, and sometimes they show it like this. And this is normal open. So normal open, normal close, normal close, and normal open. Now start and stop, we can show it like if we have a start and stop circuit or switch, then we show the stop like this, and we show the start like this. This is a start, and this is a stop switch. Okay, now that I've explained all the parts, we're going to go downstairs and I'm going to show you a practical version of a contactor and how we connect them. Okay, thank you so much. That's the theory part for this. And keep an eye out for an announcement, please. Yes. Yes,